Building Information Modeling, BIM, integrated workflows are maximizing value for mechanical, electrical and plumbing design in unprecedented ways. The traditional process is sequential, inefficient, and time-consuming, leading to errors and delays, which result in higher design costs and suboptimal design. On the other hand, BIM facilitates interconnectivity between all the stakeholders by enabling real-time coordination, so that architects, engineers, and owners can work concurrently from a central model to make it fast and efficient. This allows us to create an optimized design with error-free iteration, so that your project can remain ahead of schedule. With BIM integrated design, mechanical and plumbing firms gain certainty in calculations. That certainty allows us to reduce the safety factors from 20% to 5% by removing the need to oversize equipment. With BIM integrated design, we can also optimize the equipment sizes and material usage, resulting in up to 40% savings in design time and up to 25% savings in project costs. At Pinnacle, we use several design and analysis software, along with in-house software models, to create multiple iterations of a BIM model to optimize its cost and enhance its value. We provide comprehensive design support for all mechanical and plumbing design stages. Our BIM integrated workflow for mechanical design begins with heat load calculations. The steps are ensuring perfect measurements, assigning design criteria, and calculating the load using our software platform. Once the load is calculated, we select the relevant equipment by prioritizing performance, cost, maintenance, and efficiency for mechanical ducting and mechanical piping. While making our recommendations for air terminals, we consider space type, interior design information, airflow, total pressure, throw, and noise criteria. Duct sizing. The ducts are sized based on volumetric airflow. Now, we calculate the external static pressure. This is the pressure required by the fans inside any HVAC equipment to deliver the required airflow rate, so that the air can reach from the HVAC equipment to even the furthest index point. After the ducts are sized and air terminals are placed, we create the layouts for duct routing. And, just like that, our model is complete. From this point on, we generate visually informative riser and isometric drawings that allow clients to evaluate the building's systems in 3D and 2D space. We also create detail section drawings that allow you to explore, evaluate, and enhance your project in granular detail. Creating an itemized list of equipment, along with costs and quantities, is the final step, allowing you to control and optimize your budgets. Similarly, our BIM integrated workflow for plumbing design offers accuracy with quick turnaround times. We begin with placing fixture units that are used to determine water supply to fixtures in their service systems. It is rare for all fixtures in a system to be used at the same time, so the total units achieved by adding the numbers for all the fixtures is then compensated for their intermittent use. From there, we begin creating riser and isometric drawings that indicate water, drain and vent lines being installed, along with all the pipe sizes and cleanouts for the sanitary system. We combine BIM integrated tools with traditional methods to provide clients with accurate and optimized results for water supply, waste and vent, medical gas, and natural gas. We geometrically arrange pipes from the water supply to each individual plumbing fixture, optimizing the system efficiency and minimizing energy costs. We design efficient stormwater systems that include carrying the stormwater runoffs from roof drains, courtyards, and drains to a predetermined disposal site. Using our detail and sectional drawing, you can evaluate the building model in granular detail, and isometric projection allows you to view our 3D models in 2 dimensions. Now, we create a schedule of all the plumbing fixtures listing sizing and other details. This provides an easy reference for users during construction and maintenance. The final step is extracting the quantity takeoff that facilitates procurement planning and helps you optimize your costs. Our BIM integrated workflow for electrical design begins with illumination calculation, where we determine the optimal amount of light required by the building's occupants, while optimizing energy costs and resource usage. From there, we determine the steady-state operating characteristics of the power system for a given load, the generator's real power, and voltage conditions. In short circuit analysis, we validate the stability of the network, and provide accurate element parameters, to determine the currents that flow during an electrical fault, minimizing risks while optimizing output. Post-load calculations, we derive accurate specifications of elements, as per applicable codes and standards, including cable sizing, conduit sizing, conduit routing. All cable trays are sized as per the NEC, and have a minimum of 20% additional capacity, allowing for greater flexibility, in supporting both the initial design and future cabling requirements. The next step is adding the information, for expected loads in the facility, and listing their characteristics in panel schedules and fixture schedules. Single line diagrams contain the breaker sizing information, cable, and conduit sizes, along with mechanical equipment power connections. Detail and section drawings provide information about the assembly of components, and the junctions between them to show construction details, detailed form, and so on, and isometric drawings allow you to evaluate our 3D models in a 2D layout. Electrical riser diagrams display the major electrical equipment in a building, floor by floor. Here, you can see the feeders, bus risers, bus plugs, panel boards, transformers and other major items of equipment. Circuit connection drawings arrange all the components of the electrical circuit, in their actual physical locations. These are designed for the end users, helping them install connections and troubleshoot components. The final step is extracting accurate quantity takeoff from the 3D model. This aids material procurement, and allows you to optimize costs easily and efficiently. To create a 3D model, we require the following from our clients: architectural plan, preliminary design concept, design reference, applicable codes, project specifications, approved equipment schedule. We are highly flexible, and work with a wide variety of input formats, such as hand sketches, single-line diagrams, red-line sketches, schematics, design excels and more. Finally, here's a few kind words from our clients.
Wenbo Wang says great progress on load calculation in such limited time. Great drafting format. Very organized and responsive as always. Jake Mitchell says, MEP Delta is very satisfied with all the work Pinnacle has produced for us. Ryan Sullivan says, I thought this project went very well. I like the weekly meetings and frequent progress drawings. Josh Devon says, the willingness to see things through, attention to detail, and communication throughout the project shine through in their work.
Reach out to us for your MEP design needs at pinnacleinfotech.com.